this is group 7, and we had chapter 18, which is 2 classes of chemical reactions. My name is Amber Skinner. There's also Tavian Austin, Rashawn Deloyd, and Morgan Boomer. First up, I will be doing what are acids and bases. An acid is any chemical that donates a hydrogen ion. A base is a chemical that accepts that hydrogen ion, and when both of those both acids and a base reacts, it's called neutralization reaction. My next one is hydronium ion versus hydroxide ion. A hydronium oxide is a water molecule with extra protons, and a hydroxide ion is a water molecule without nucleus of one of the hydrogen atoms. And below is a picture showing a hydronium ion and a hydroxide ion. The relative strengths of an acid and a base. The stronger an acid is, the more likely it is to donate a hydrogen ion. The stronger the base is, the more willing it is to accept that hydrogen ion. The 6 common strong acids are hydrogen chloride, hydrogen bromide, hydrogen iodine, nitric acid, sulfuric acid, and perchloric acid. One way to assess the strengths of an acid or a base is to measure how much of it is left in the water after it's added to water. How much of it is left after it's added to water? If it's little remaining of the acid or the base, it is strong. If a lot is remaining, it is weak. Corrosion in acidic and basic solutions. A solution with only a little hydronium and hydroxide ions are considered a very dilute solution of an acid or a base. A concentrated solution of a weak acid can still be just as corrosive or even more than a diluted solution of a strong if there is a greater concentration. Therefore, the relative strengths of 2 acids or base in a solution can only be compared when 2 solutions have the same concentration. And that is
I'm Tavian Austin. I'm going to be talking about acidic, basic, and neutral solutions. The amphoteric, a substance that has about the same ability to behave as a base or an acid. For example, my water molecule. The constant Kw in the formula, Kw is the concentration of the hydronium ions in an aqueous solution multiplied by the concentration of the hydroxide ions in the solution. It's important because no matter what is dissolved in the water, the product of the hydronium ions and hydroxide ions concentration always equals 1 times 10 to the negative 14. Neutral solution. Any solution with an equal number of hydronium hydroxide ions. An example of this is pure water because it contains equal numbers of protons. It explains why they are said to neutralize each other because there are equal quantities of acid and base combination combined. The pH scale is a numeric scale that expresses the acidity of a solution. It equals the negative log of the hydronium ion concentration. So right here it shows pH equals negative log times hydronium ion. So if it's less than 7, it's an acidic solution. If it's equal to 7, it's a neutral solution. And if it's more than 7, it's a basic solution. Acidic rains. Water and carbon dioxide reacts to form carbonic acid. So carbon dioxide plus water yields carbonic acid. Carbonic acid behaves as an acid and lowers the pH of water. The normal pH of rainwater is between 5 and 7. The neutral acidity of rainwater has the potential to accelerate erosion of land and creates underground caves in certain circumstances. Rain with a pH under 5 is considered acid rain. It is created when airborne pollutants are absorbed by atmospheric measures. Basic oceans. Carbonic acids in oceans are quickly neutralized by dissolved substances such as calcium carbonate. This in turn increases the pH of the ocean water and gives the name of basic oceans.
My name is Morgan Balmer, and I'm talking about losing and gaining electrons. Oxidation is the process whereby a reactant loses one or more electrons, and reduction is the process where a reactant gains one or more electrons. This is an example of an equation. This is what happens when oxidation occurs, and this is what happens when reduction occurs. The net result is that the 2 electrons lost by sodium atoms are transferred to chlorine atoms. Each equation represents 1/2 of the entire process. Oxidation and reduction. Sodium won't be lost without a presence of a chlorine atom available to pick up the electron. A reducing agent is any reactant that causes another reactant to be reduced, and sodium is oxidized when it behaves as a reducing agent. It loses electrons. Chlorine causes oxidation of the sodium, and so it is acting as an oxidizing agent. To help you remember, you do Leo the lion goes grr. Loss of electrons in oxidation, gain of electrons in reduction. Harnessing the energy of flowing electrons. Electrochemistry is the study of the relationship between electric energy and chemical changes, for example, batteries and fuel cells. A fuel cell is a device that converts chemical energy of a fuel into electric energy. It is possible to harness electric energy from oxidation reduction reaction. These are called voltaic cells. Voltaic cells can be all in one. This would be called a battery. Batteries. The most common batteries would be the disposables, dry cell batteries, alkaline batteries, and nickel metal hydride batteries. Dry cell batteries are most common among disposables. Alkaline batteries are more expensive, however they are common, and nickel metal hydride batteries are rechargeable. These batteries have a reversibility of the oxidation and reduction reaction. This is an example of the reaction, and the role of the nickel is to stabilize the 2 electrons on the hydrogen.
My name is Rashonda Lloyd once again, and I'm going to start out by talking about electrolysis. Electrolysis is the use of energy in order to produce a chemical change. An example of this is whenever you're recharging a car battery, because what you do, you plug it up and electric energy goes through the cords and the chemical reaction occurs for it to charge. It is also used to purify metals from metal spores to other things. So it's kind of like aluminum is an example of that. The Hall-Héroult process is known because of Charles Hall and Paul Héroult. And before 1855, like during that time period, it was a rare material. Aluminum was a rare material. And it was only available in luxurious places, kind of like Paris and places in France. So in 1866, whenever they discovered this process, it became very valuable to the economy and the history of aluminum because it made it more available. So what they did is that they discovered that a strong electric currents pass through a molten mixture of aluminum oxide and cryolite. Those two, whenever they combine, they make fluorine ions. And these ions react with aluminum oxide to form various forms of aluminum fluoride ions. And they're oxidized to hexafluoride ions, and they're pushed out of the chamber, which gives us the elemental aluminum. And since then, the prices have dropped tremendously, and you can get it really cheap. Another thing that's very important is corrosion and combustion. Corrosion and combustion are 2 common oxide reduction reactions involving oxygen and the oxidizing agent. Corrosion is the deterioration of a metal that is typically caused by oxygen that is in the atmosphere. Combustion, on the other hand, is an exothermic oxidation reduction reaction that occurs between a non-metal material and a molecular oxygen. The breakdown of corrosion. So whenever I'm gets broken down and it corrodes, a material called rust forms. However, there are some ways to protect iron and other metals from getting this rust material because of oxidation. They are galvanization, cathodic protection, and electroplating. Galvanization is the process in which a thin layer of zinc forms on an iron object due to zinc's slightly higher tendency to oxidize an iron, and therefore protects the iron underneath the rusting. Cathodic protection is a technique that protects iron structures from oxidating by placing them in contact with materials that have a greater tendency to oxidize, such as zinc and magnesium. This forces the iron to accept the electrons, meaning that it behaves as a cathode. Examples include ocean tanks and outdoor steel pipes. Electroplating is the third process, and it deals with electrolysis. And it is the operation of coating one metal with another by way of electrolysis. An object is connected to an electrode made of the coating metal. The circuit is complete when the electrode is completely submerged in solution. Dissolved metal ions are attracted to the negatively charged object, where they are picked up by the electrons and deposited in the metal atoms. The ions in the solution are replenished by the forced oxidation of the coating metal at the positive electrode. So now we're going to talk about how combustion works. Electrons are transferred when polar covalent bonds are formed in place of nonpolar covalent bonds, or vice versa during this process. And after combustion, however, on the downside, the electrons are shared between oxygen and hydrogen atoms, and water molecules are pulled back to oxygen. This gives the oxygen a slightly negative charge it has gained because of the electrons, and it is considered reduced. An example of this can be seen below with the human body metabolism, because what we do is we intake oxygen and we produce energy and carbon dioxide and water because of combustion. So that is our presentation. Thank you.